This is Advanced Math, Unit 11, Lesson 2. We're still dealing with conic sections. So far we've had circles, today we have parabolas, we will have hyperbolas, or ellipses and then hyperbolas will be coming up in the lessons to come. Okay, first thing we're going to review is standard form. Different textbooks, different people have different, they call standard form different things. For us, we're going to call this standard form, which is the same standard form that we used in Math 2. I'm not sure what you called standard form in Math 3, I would have to check. But y equals ax squared plus bx plus c is what you did use in Math 2. Okay, so quick review. When you're given a function, a quadratic, this is a quadratic in standard form, LOS is line of symmetry, or your line of symmetry is always an equation. X equals negative b over 2a. That is review, that is not new. Okay, so your line of symmetry is x equals negative b over 2a. And your vertex, you do the negative b over 2a as your x value, and then plug it in and find your corresponding y value. Okay, so that's just a quick what you should already know. I'm just going to show you really quick. When x is being squared, your parabola will either open up or down, depending on your a value. If your a value being that, if a is positive, it's opening up. If a is negative, it's opening down. All of this is review as far back as Math 2. Okay, this next piece is what you learned new last year. X equals ay squared plus by plus c, which are parabolas that open sideways, either right or left, depending on your a value. And the first one here is if a is positive, a positive value, and if this one here is if a is a negative value. Again, you didn't do this one in Math 2, this was new for you guys last year. And the LOS, the line of symmetry or the axis of symmetry, instead of x equals, it's going to be y equals, still negative b over 2a. It's x equals in these two because your line of symmetry will always be vertical, which is always x equals equations. And on sideways parabolas, your axis of symmetry or line of symmetry is always horizontal, which will always be a y equals equation. And then you find your vertex very similar to what you would do up there. So let's write that down. Vertex, you'd plug it in, but this is y, not x. So when you plug it in, you plug it into your y value, the negative b over 2a. You would plug it into your y values of your original function and solve for the corresponding x value. Okay, next quick piece of review is same thing but in vertex form. Y equals a quantity of x minus h squared plus k, or y equals a y minus k quantity squared plus h. Okay, on these we typically find the vertex first and then the axis of symmetry, but it doesn't matter, you can find them in any order. Okay, so the vertex is hk, which is why this is often called descriptive form. It is vertex form, but many times I'll call it, or you'll hear people call it descriptive form. Descriptive form, and the reason is you can look at it and it describes the way the parabola moves. It moves h units to the right and k units up or down, or this could be right or left depending on the value. Okay, and the LOS, line of symmetry, is x equals the h value, and it's always opposite. If you remember that, opposite of the inside, outside stays the same. Opposite of the inside, h, outside stays the same, k. Okay, and this one is similar. The vertex is also hk, noticing that here h is with the x and here k is with the y. Do you see that? HK, well, over here it's KH. So they flipped around. You do need to remember that. LOS is y equals the k value. X equals the x value, y equals the y value. You will need to remember this because it's, again, this is something you have done. The top one of each one, the standard form and vertex form, the original ones, are ones you've learned since Math 2. These bottom two here are the new ones you did last year in Math 3. Okay, some vocabulary that I want to quickly review. I am going to make a total of 4 of these across the bottom, so make sure you're giving yourself enough room. I'll do 2 of them first, and then the next 2 in just a bit. All right, a parabola that opens up or down. And it doesn't matter where you draw your parabola. You can put your vertex anywhere as long as one of them is opening up and one of them is opening down. Okay, some key vocabulary words that you will need to know. You already know that that's the vertex, so I'm not going to label that again. We should already know that is the vertex. Okay, some key points are, I'm going to go ahead and draw in the axis of symmetry or line of symmetry. You should know that is there as well. Okay. Focus is always a point inside your parabola. It's always a point. Focus. Focus. Plural foci, or foci, depending on how you want to say it. Okay, so you will need to know that a focus, or the focus, is always a point inside your parabola. That is review. You've done that since last year. Okay, your directrix is always a line outside of your parabola. That is your directrix. And I'm going to rewrite that somewhere else so I have enough room for my next graph. Okay, so that is the directrix, and again that line is the directrix. So you will always have 2 points and 2 lines. 2 points, the vertex and the focus, the vertex and the focus. 2 lines, the line of symmetry and the directrix, the line of symmetry and the directrix. For your line of symmetry and your directrix, one will always be x equals, one will always be y. In this case, x equals for your line of symmetry, y equals for your directrix. Again, that should be review. And they're always equidistant. From your vertex to your star or your vertex to your dotted line, equal distance. If you went up 2, you go down 2. If I went down 1, I go up 1. They're always equal distance. Okay, again, this should not be anything new to you because you did do this a lot last year. Actually, maybe beginning part of second semester. Okay, here we're going to draw some sideways parabolas. Doesn't matter where you put your vertex, just draw in a sideways parabola. I'm going to draw one opening right and one opening left. I'm going to draw in my, this here is my axis of symmetry, so that would be my y equals line because it's horizontal. And just like the other ones, it has a focus inside and a directrix outside. It has a focus inside and a directrix outside. Okay, so things you cannot say. You can't, for these here, you cannot say, oh, the focus always goes up, because sometimes it goes down from the vertex. Some kids will say vertex always goes up, focus always moves up from the vertex. Not true, because here the focus moves down. Or here they'll say, oh, from the vertex always move to the right for the focus. No, because here you move to the left. So what you can say is the focus is always inside the cup. Whether it moves right or left, it's always inside the cup. And the directrix is always outside the cup. Got it? All right, let's move on. Let's just do two quick examples, and when we'll do more examples together in class. Okay, I am going to have you sketch and I'm going to also have you find some key points. Okay, so let me give you the equation. Y equals 2 parentheses x minus 4 quantity squared plus 3. And the key points I want you to find is V for vertex, F for focus. Remember, focus is a point, so I'm going to put an ordered pair. Your equation for the LOS and your equation for the directrix. Remembering these two are your points, these two are your lines. One of these will be x equals, one of these will be y equals. Okay, so we're going to sketch and then find these key pieces of information. All right, so vertex first off is 4, 3. Opposite of the inside, outside stays the same. This is vertex form or descriptive form. So you would say 4, 3. All right, so let's go ahead and graph. And it's positive, so it is opening up. Okay, over 4, up 3, and I'm going to go ahead and draw my axis of symmetry in there now, or line of symmetry. And that there is a vertical line, so it's x equals, it crosses 4, so my line of symmetry will be x equals 4. And we could get that from right here. The LOS is x equals the opposite of the inside. The opposite of -4 is +4, or the x value of your vertex. Okay, it's opening up, and you may remember the bigger the number, the thinner the graph. It's not truly highly important in this problem, but it's opening up and thin. Okay, now in order to find the focus and the directrix, I need to know the focal length. So I am going to flip this page over, and there should have been a formula I gave you and did not. So we're going to quickly add it in down here. And this is your focal length formula. Focal length formula. And your focal length formula is C equals 1 over 4 times the absolute value of A. 1 over 4 times the absolute value of A. A being your leading coefficient, absolute value. So if it's negative, make it positive, and then plug it in. Okay, so with that being said, let's go ahead and find our C value being the focal length. 1 over 4 times the absolute value of 2. Well, the absolute value of 2 is just 2. So it's 1 over 4 times 2, 1/8. What this means is for my vertex, I'm going to move up 1/8, down 1/8, and be good. Up 1/8 would be the focus because it's always inside. Down 1/8 would be the directrix because it's always outside. Now here is what you have to remember. It's always from the vertex. So one of these values will be changing, either the 4 or the 3. If I went over 4 and up 3, and then from this point I'm moving up and down, can you see that's the y value that's changing, and the x will stay 4. So x is going to stay 4 and it's not going to change. Why? Because from here I'm going to move up a certain distance. Don't draw this in with me, I'm going to erase it and put a star. So when I move up, I'm still going to go right 4 and up a certain value. Okay, so let's figure how far up. Going up is plus, and when I'm moving up, what value is changing? The 3, the y value of your vertex. So we're going to do 3 plus 1/8, and then 3 minus 1/8. 3 plus 1/8 is 3 1/8, which makes sense because if I went over 4 up 3 and then up 1/8 more, that would put me at 3 1/8. 3 1/8. Okay, now I'm going to do 3 minus 1/8. So imagine you have 3 whole items, you take 1/8 away from one of them, that leaves you with 2 whole items, and then 7/8 of your third item because you took 1/8 away of one of them. Or you can do it by hand, common denominator, however you want to do it. Okay, now that means if I'm subtracting from 3, that means I'm moving downward, which means I'm doing the directrix. Now remember, directrix is not always subtract, nor is the focus always adding. It just depends on the direction your parabola is opening. Okay, so that is y equals, because it's horizontal, y equals, and I went down to 2, I went down 1/8, which means I'm at 2 7/8. 2 7/8. And that should make sense graphically as well. You can see that point is bigger than 3 or higher than 3, and this line is below the 3. So 3 1/8, or 4 comma 3 1/8 for the focus, and y equals 2 7/8 for the directrix. Typical type of test question. Okay, next piece we're going to do is working backwards. Okay, write an equation and sketch. Write an equation and sketch. Okay, I'm going to give you information. We're going to work backwards. V for vertex is 5 comma 4, and your focus is 2 comma 4. Remember, we will do some more examples in class because the notes will be really long if we did a bunch together. Okay, oh, didn't give it to you. Focus is 2 comma 4. Said it, didn't write it. So first thing I'm going to do is sketch at least what I'm given and figure out from there what to do. Okay, let's scooch this over. And go right 5 up 4. Okay, over 5, up 4. Okay, and then the focus, this is the focus point right there, is 2 comma 4. Over 2, up 4. Okay, so I put a dot typically for my vertex and a star for my focus. They're both points, but I do that just so I can visually see. So if I just draw 2 points, which one's the focus, which one's the vertex. So that's why I use 2 different ones, a point and a star. Point for the vertex, star for the focus. Point for the vertex, star for the focus. Okay, so remember the vertex, the focus is always inside the cup. We talked about that here. It doesn't matter which direction the parabola is opening, up, down, right, or left. The star is always inside the cup, which means this parabola has to open to the left. That's the only way. If it opened up, the star would not be inside. If it opened down, it wouldn't be inside. And if it opened to the right, it still would not be inside. So the parabola must be opening to the left, which means it is a sideways parabola, so y is squared, not x. Okay, so we can at least start there. So we're going to have an x equals, instead of a y equals, a. And I'm just going to write down the skeleton of it, y, and I'm using this right here, this one right here. So I'm actually, before that, I'm just going to write down the actual formula. Y minus k, quantity squared, plus h. Do you see that? Again, I'm just getting that from the previous page. Y minus k, quantity squared, plus h. Okay, where h and k are the values here. H, K. And I'm going to fix that because, no, I don't have to in this one. I have to fix it in there. Sorry. Okay, HK. Opposite, inside, outside, same. X equals A, Y minus K value is 4 squared plus 5. If you were working backwards and I asked you to find the vertex, you would say opposite of the inside, outside stays the same, positive 4, positive 5, but they would be flipped around because the y is on the inside. So positive 4 goes in the y spot, positive 5 goes in the x spot. You should remember that from last year. Okay, so the only thing I have left to find is my a value. I don't know what the a value is. What I use is the fact that we know that c equals 1 over 4 absolute value of a. All right. I don't really work the absolute value in there. We just kind of have to take care of it at the end. C equals 1 over 4a. Now remember, C is the focal length. It's the length from your vertex to either your focus or your directrix, depending on which one's given to you. In this case, it is the focus. So I'm going to count the length between the 2 points. If it had been the directrix, then I would do the same thing. I would count the length between the vertex and the directrix. But since it was the focus given, vertex to focus, and you're going to do a lot of this in your work and examples and quizzes and tests. So count this length right there, and you should see that that value is 3. C equals 3. Which means when I did my C equals 1 over 4a, did all the work, C ended up being 3, so I went from here and moved over 1, 2, 3. I would then go 1, 2, 3 and do a dot, 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 dot. Okay? So again, because now I know it, I can go 1, 2, 3 and draw my directrix because I know these are equidistance. Okay, so I can use this, this equation. 3 equals 1 over 4 times a. I don't know what a is, that's what I'm looking for, but I know once I plug it in, I would get 3 as my answer. So I'm just going to cross multiply or multiply both sides by 4a, however you want to think of it. 12a equals 1, divide a equals 1/12. The only thing you have to work with is because we take the absolute value of a, when we do these formulas, you don't know whether it's positive or negative, so you have to look at the graph. If it's opening to the left, what does that mean? That means that a must be negative. So when I plug my a value in, I need to make sure that I make it a negative. I'm going to leave it there and I'll just rewrite it. Negative 1/12 y minus 4 quantity squared plus 5. That there would be your answer. And that is it for this lesson. We will do more examples together in class.